PN junction diodes. Okay, that is transistor consists of two PN junction diodes or two PN junctions back to back connected. Okay, this is the transistor. This is a picture of a transistor. Another type of transistor, three terminal transistor has three terminals: collector, base, emitter. Okay, then what is the work of collector, base, and um, collector and emitter working principle, and what is a collector made up of which type of material, base and electors, emitters, those are um, made up of what kind of materials. This is what we are going to discuss today, and then some biasings also we are going to discuss. Okay, this is a picture of a transistor already seen in the laboratories. There is three types of, three models of transistors is there. This is one type of model. Another two types will show you in the next slide, or end of this slide I will show you. Just these are these three transistor are same, the working principles are same, but design is very different. Okay, this is the basic transistor, that is mainly uh, two PN junctions back to back connected. That's all. That's a transistor. It has three terminals: collector, base, and emitter. Okay, and this is the symbol of transistor. It is classified into two types: PNP and NPN. And what is PNP, what is an NPN in detail we will discuss later. Okay, this is PNP transistor, symbol of PNP transistor, and collector, base, emitter. This is NPN transistor. Yeah, what is the difference between these two means, uh, by symbol wise we can identify by this arrow. This arrow mark will indicates the current flow direction. Okay, current flow direction. For PNP transistor, current flows through the emitter and reaches base, and again reaches the collector. What is the principle is using inside the transistor we will discuss. Then this is for NPN transistor. The holes are moving in emitter, but electrons are moving opposite to the holes direction. So currents come out from the emitters. This is the NPN transistor. This is the difference between PNP and NPN. Here, what is PNP? How we can say PNP and NPN means nothing but P-type material, N-type material, another P-type material. That's all. Here on junction, this is the NPN transistor. Here N is a N-type semiconductor material, P is the P-type semiconductor, another N-type semiconductor materials are sandwiched. Okay, this P-type semiconductor sandwiched between two N-type semiconductor, that is NPN transistor, and the N-type semiconducting material sandwiched between two P-type semiconductor materials, that is called PNP transistors. Okay, then in between two NPN transistor, it has a P-type semiconductor material. That's a very thin layer of P-type material in NPN transistor. For PNP transistor, here N-type materials, N-type semiconductor materials are very thin layer in between P-type and in between two P-type semiconducting materials. This is the structure wise there were difference between NPN and PNP transistor. Okay, is it clear?
Yes, sir. Yes, sir.
Again, okay. Again, some clarifications about PNP and NPN. Here, this is the PNP, and already we know that N-type semiconducting material, a thin layer of N-type semiconducting material sandwiched between P-type and N-type, that is PNP transistor. And one type, collector side, um, P-type materials are lightly doped. Then emitter side P-type materials are highly doped semiconducting materials. Okay. And one by one, collector, base, and emitters, one by one I will discuss. in the next slides. Then this is for NPN transistor. Here collector side இருக்கிற அந்த N type material that is lightly doped. Here emitter side highly doped. Okay, that's a difference between PNP and NPN. The same symbol. Then inside the transistor, just already we know that two PN junctions. Which means two different PN semiconductor diodes, two diodes inside the transistor. Okay, here this direction, another diode directed towards the emitter. This is the inside the semiconducting material, a transistor. This is a symbolic diagram working here. It shows the junction of transistor, that's all. There is two different diodes taken and combined with the inside the transistor. It's not at all okay, just a symbolic purpose. There are two PN junction, here PN, here another PN. Okay, that's all. That's the symbolic of the transistor we are using. um, Two diodes, two diode purpose. உள்ள ஒரு டிரான்சிஸ்டருக்குள்ள ரெண்டு டயோடு இருந்துச்சுன்னா எந்த மாதிரி ஒர்க் ஆகுமோ அதை தான் டிரான்சிஸ்டர் பண்ணோம். ஓகே, transistor, before proceeding the working principle of transistor, it is classified into two main types. One is BJT and FET. Okay, BJT means bipolar junction transistor, and FET means field effect transistor. Okay, again bipolar BJT, bipolar junction transistor, again classified into two types, NPN, PNP. That is we have discussed already. Okay, then FET is classified into two types, JFET, MOSFET. JFET means junction field effect transistor. MOSFET, metal oxide semiconductor field effect transistor. Okay, again further classified depletion and N channel, P channel. MOSFET again depletion, enhancement, another N channel, P channel, and from enhancement to N channel, P channel. Further we will discuss in detail in the next classes. Okay, about FET. Now we are going to discuss about first type, BJT, bipolar junction transistor, and its types, NPN and PNP. Okay, in transistor we know that three terminals is there: emitter, base, and collector. Simply you can say this is related to our city Coimbatore. CBE, that's a short form. CBE for Coimbatore. CBE, collector, base, emitter. We can easily um, remind easily with the Coimbatore CBE. And I will show in last slide, or after searching in the internet, I will show the laboratory use transistors, then how to find out the terminals from the transistor. I will show you the last session, end of the session. Else I will explain in some other day. Okay, the close relationship, relationship with Coimbatore CBE, we can, this is a shortcut for collector, base, emitter. Okay, first terminal, emitter. What is the emitter? What kind of material is made up of? These all things we are going to discuss. For emitter, the emitter section supplies the charge carriers. Okay, uh, emitter means it supplies charge carriers to the transistor. Okay, this is the input terminal. You can say simply it is the input terminal, that is the charges is going through the emitters to the transistor. Okay, the emitter section is heavily doped. Already we seen in that diagram. The emitter section is heavily doped so that it can inject a large number of charge carriers into the base. Here the diagram, where is here emitter, the current is for example in PNP transistor, current is flow through this emitter terminal and reaches the base. Okay, the size of the emitter is always greater than base, uh, because base is in center part, I mean center part of the transistor always is thinner, okay, whether it is n type or p type, the thin layer of material in between two sandwiched p type or n type semiconducting materials, that is transistor. For emitter, that is always greater than the base, okay, size, and compared to collector, emitter is um, greater than the collector. Then base, it's a middle layer of a material, semi transistor. It is lightly doped. Emitter is heavily doped. Base is the lightly doped, that is located in between the emitter and collector. Okay. Then third terminal, that is collector. It's a usage of collector is to collect the currents from the base. Okay. In emitter, the currents are allowed through the to the transistor and flow through the base and reaches the collector. What kind of mechanism is using inside the transistor? We will discuss one by one. Okay. Then this is the collector is a moderately doped semiconducting material. Emitter is a highly doped material. Base is the lightly doped material, and the collector is the moderately doped semiconducting. Okay. The collector area is the transistor considerably large than the emitter area, because the collector needs large surface area to dissipate the current, I mean dissipate the heat. Okay, a large current is flowing through the collector means it produces heat. So to dissipate heat through to the surroundings, it requires large surface area. So collector is large when compared to other two terminals, I mean two semiconducting materials. Okay, these are all the terminal uh, distribution and explanation for emitter, base, and collector. Okay.